This video is a worked example of a sample Chapter 1 quiz for General Chemistry 1 courses at a university level. So question 1 right off the bat, if a matter is uniform throughout, and I'm just going to emphasize uniform throughout, and that should automatically put you onto homogeneous mixture. So I'm not even going to read anything else. I'm just going to say homogeneous mixture. And can be separated into other substances by physical... Wow, that was really extra. By physical processes, it's obviously not a compound because it's not physical. Homogeneous mixture. Let's do it. Yeah, correct. Which one of the following is true for intensive properties, right? Intensive, remember, is independent of quantity. So, depend on quantity. No. Cannot be used to identify a substance. No, they can be used to identify a substance. They cannot directly be measured. Yes, they can. So obviously, by process of elimination, it is B. 3, so we're just going to go through this really quick. A is element, B is molecular compound, C is ionic compound. Let's do it. Remember, molecular compound is 2 nonmetals, and this is metal, nonmetal, right? And this is just element, right? So, 2 nonmetals, molecular compound. Okay, 1 atomic symbol, element. All nonmetals, molecular compound. Metal nonmetal, ionic compound, right? Metal nonmetal, ionic compound. Metal nonmetal, ionic compound. Nonmetal nonmetal, molecular compound. Metal, nonmetal stuff, ionic compound. That's a gross looking C. And again. Wow. There we go. We had a time. How many significant figures are in each of the following numbers, right? 1, 2, 3, and 4. This is just 1. 3. And in scientific notation, you go for all of them. So, 4. 4, 1, 3, and 4. Remember that left leading 0, placeholder zeros are not significant, right? And right zeros are significant. So, when there's a decimal point. Okay? Looking at this dartboard over here, right? Looking over here, okay? Remember that precision is when all of our measurements are really close together. And accuracy is when they're really close to the correct value, or correct spot on the dartboard, right? So all of our darts are really close together, but they're nowhere near the bullseye. Right, nowhere near the bullseye. So it is good precision. That's terrible penmanship. Bad accuracy. Okay. Good precision, poor accuracy, B. Okay. Now let's just identify these phases of matter really quick before we go anywhere else. We're going to name the transition. This obviously, now if the balls were, or atoms were bouncing around off the walls and they were over here, I'd say it's a gas. I'd say those are a little bit too close together to be a gas, but a little too far apart to be a solid. So I'm going to say this is a liquid. Okay, and this is very uniform. It's very much like a crystalline structure. So we are going to say that this is a solid. Okay, remembering that liquid to solid is freezing. Okay. Now, this is something that hopefully was done early in this course. This is a more simple table to go through, right? We're going to go definite or indefinite. For a solid, what about our shape? It's a definite, right? An ice cube. Think of an ice cube. Volume, definite, doesn't change. Ice cube is an ice cube. Liquid, right? Our shape, well, we can have it in a martini glass that gives it kind of a cone shape, or we can just have it in a regular drinking glass if we had some water, obviously, because some people who are watching this video are under 21, so you can drink. Sorry. It's college. So obviously it's an indefinite shape, but a definite volume. There's always a finite amount of water. Chemistry-wise, you can put it in an Erlenmeyer flask, or you can put it in a beaker, or a Florence flask, or a round-bottom flask, and now I'm boring you. Gas, obviously, indefinite shape, indefinite volume. Gases can spread out a ton. So here we go. Just going to do some quick dimensional analysis problems and be done with this video. So here it comes. 1.48 centimeters squared to inches squared. So we're going to start with 1.48 centimeters squared. We're going to multiply that by our conversion factor between centimeters and inches, which is obviously 2.54 centimeters per 1 inch. And remember, we're going to do that twice because we are going from centimeters squared to inches squared, right? And that's all the work we need to do to get to 0.229 inches squared. Right, and we know we get 3 significant figures in our answer because there were 3 significant figures given to us in the problem. Next question is going to be the same principle, except for we're just going from millimeters to meters. Okay, so we're just using one conversion factor. We have 9.3 millimeters, right? And we're going to multiply that, right, by how many millimeters are in 1 meter. And remember, our prefix milli means 1/1000th, so 1 millimeter, okay, is 1/1000th of a meter, or there are 1,000 millimeters in 1 meter. That means we would have 0.0093 meters, and notice I'm keeping 2 significant figures because I was given 2 significant figures in the problem. And I can rewrite this, those 3 lines kind of mean just like equal to in chemistry, so we avoid writing arrows if we don't have to. So we could also write 9.3 times 10 to the negative 3 meters, and either one of those is correct. You can write either one, and we'll take it. All right, last question is just another dimensional analysis problem, so just because we're giving you density, don't get scared. We're going to just write down that we have 57.0 grams of sulfuric acid, right, which is 1.84 grams per milliliter. I want the volume, okay? And since we're not specifying a legit solitary finite unit to put your volume in, you can just leave it in milliliters. If it's given to you in the density, it's totally reasonable. So we're going to write 57.0 grams, right, times, right? Now we want milliliters. We're going to have milliliters on the top, right, and my 1.84 grams on the bottom, right? And we can see that this comes out to 31.0 milliliters. Or, if you want to be super fancy, you can write 0.0310 liters. We'll take either answer. So anyway, that is a walkthrough of a sample Chapter 1 General Chemistry 1 quiz. If you have any questions, please feel free to ask your instructor or reach out to students in your class or student staff that are there to help you.